Hello, everyone. So I'm Saray. I'm an engineer at Wayfair. I've been there for about 6 years now. I spent the first 3 years building applications with GraphQL, React, fun stack, right? Last 3 years, been on the GraphQL platform team. This is where we enable our organization to succeed and build with GraphQL and kind of just making it easier for teams to build with GraphQL and Federation and go into production. So this is Schema Contracts, the most powerful GraphOS feature you're probably not using. So on the agenda for today, we'll take a look at an overview of Wayfair and GraphQL, more specifically the earlier stages of Federation, and some of the pain points that we saw as we were venturing into Federation. Then we'll take a look at an overview of what contracts is and how we've set it up at Wayfair. And then lastly, we'll take a glimpse into how we've adopted it at Wayfair and how you can consider using contracts in your organization. Just to kick things off, Wayfair is an e-commerce company that offers everything home. So we serve customers with very specific styles and different segments that cater to all demographic. In addition to Wayfair.com, we have other specialty retail brands as well, such as All Modern, Birch Lane, Joss & Main, and Paragold as well. And at Wayfair, we're serving over 22 million active customers right now, and that's backed by 14 million products in our catalog. So with that, we're working with over 20,000 suppliers to help deliver those products, along with our 14,000 employees to fulfill our customer needs. Across those applications, it's all powered by GraphQL. And from our mobile web to our mobile and web customer-facing apps, we have supplier portals, we have employee-facing applications, and there's just a lot of applications, and we strive to build a great app experience across those spaces. So across those experiences, they all kind of revolve around products, right? And being able to have great parity across our applications that surface product information is really crucial, right? Like, for example, we don't want wrong pricing data across our applications, right? That's supposed to display the same information. And on the other hand, there are also data that are only shared across subsets of those experiences. Like, for example, product sales data. That shouldn't be visible to customers, right? We only want to surface that to our suppliers and our employee applications. So with that in mind, I want to turn to a quote from Principled GraphQL around the idea of having one unified graph. So the quote says, "When teams create their own individual graphs without coordinating their work, it is all but inevitable that their graphs will begin to overlap, adding the same data to the graph in incompatible ways. At best, this is costly to rework. At worst, it creates chaos." So earlier in our GraphQL and Federation journey, we felt those pains because we did just that. We had multiple application-bounded supergraphs that were disconnected per experience. With so many shared concepts across our applications, we lived through a lot of those pains. And let's take a look at some of the high levels of those pains that we ran into with the many graphs approach that we had early on at Wayfair. So the first challenge is that there's a high cognitive load for both our back-end and front-end teams consuming or contributing to that graph. And as the number of nuanced use cases grew between those applications, we saw more duplication and inconsistency. On the other hand, there's something I call orchestration transparency, or the lack of it in our earlier setup. So orchestration transparency is how easily we can figure out how data is resolved and orchestrated across many services or graphs. With a multi-graph setup, there's a lack of that transparency that can also lead to duplicate code for both clients and services. So in this example here, our clients can fetch data from multiple graphs, right, to kind of stitch that data together at the end. Even though it's federated, we have multiple graphs. So this is actually the same case for our backends, right? Orchestration can happen on our backend services between the graph services themselves. So this becomes a problem, again, going back to our consistent experience across applications. For example, if our iOS application had to go to 2 different graphs to fetch data to show our product display page, and so does our Android, there's many ways that those 2 clients can orchestrate those calls. So now there's a lot of inconsistencies in how those 2 clients resolve data and paint it to our customer. The other challenge was on the client side as well. We love that GraphQL is strongly typed, and we can take advantage of client tooling like code generation. When the client has to consume from more than one graph, the application now has to manage code generation for each of the graph, which can lead to more collisions, especially when you have common types across those graphs. And then lastly, the other huge pain point was around schema governance and boundaries. And it became really difficult to manage. So as our teams and schemas grew, having many graphs means that there's a distributed model for how we build and maintain our schema. So there was a constant and never-ending discussion around, do we need another graph, or should we merge this graph in with the other? And the key takeaway here is that these are expensive decisions to make or backtrack. So those were some of the pain points that we felt with our many graph setup. And we knew we wanted a bespoke solution that can help us scale our graph ecosystem and applications without compromising on things like security and maintainability. So we actually partnered with Apollo to come up with an enterprise solution that can help us scale our graphs from looking like this to this. So less orchestration, everything's powered by that single Supergraph. And what we came up with was contracts, which is what enables us to achieve that single unified graph. So contracts is a GraphOS enterprise feature that allows us to deliver different subsets of our Supergraph to different consumers. And what this really means is that all subgraph schemas are published to a single and complete Supergraph schema. And what we can do with that is apply some filtering rules to then create what we call contract schemas. At a high level, our subgraphs are able to contribute to that one Supergraph that we just looked at that we call the source variant. That source variant contains schema definitions as well as contract metadata that is then used to filter down to our contract schemas. And the contract variants are the actual Supergraph schemas that Router can use to serve data to our clients. So let's take a closer look at that. Starting with the subgraphs on the left-hand side here. So at the subgraph level, contracts are driven by the tag directive. The tag directive actually empowers subgraph owners to decide where specific fields in their graph should be visible or queryable from. And multiple tags can be applied per location. And in this example here, the author type has the full name field, which is tagged with public and private, so you can apply multiple. And then the author ID field only has the private tag. Another contract-driven directive is inaccessible. And as the name kind of says, it's used to explicitly exclude definitions from all contract variants. So it wouldn't show up anywhere. And in this example here, there's a new field called secret name, and it's tagged with @inaccessible. Just like the tag directive, it's applicable to the same set of locations that you can apply it to. But it's not repeatable because it kind of does the same thing. So at that point, we have a good working subgraph schema that uses contracts, right? And the next step is to publish it to our schema registry, in this case, GraphOS. And that's when GraphOS composes the source variant Supergraph schema. And the main takeaway I want to call out about the source variant schema is that this isn't the schema that Router uses to serve customer traffic. So with that, let's take a look at what a source variant looks like. And as you can see, it didn't really change much. It has all the field definitions and directives, right? The whole point is that it keeps all the definitions that you have. It's the Supergraph. It has all the metadata that you need to compose your contracts. So here we have our author type, which pretty much looks the same, right? Same directives. And once that source variant is composed and it's working, it's following the specifications of federation, it'll then, it meaning GraphOS, will then generate our contract variant schemas, which is where it applies those filtering rules to generate that contract schema. And the way that contracts are configured in GraphOS is through two main rules. The first is include, so you can choose to include these tag directives in the result of your contract schema. On the other hand, you also have exclude, so you can choose to exclude certain tag directives from the resulting contract variant schemas. So in this example here, we're just creating a contract schema that only includes tags that are public. And what's nice in GraphOS is that it actually generates a preview view, so you can actually see it live as you generate your contracts. So once our contract variant schema is created using that includes rule that we just used, our contract supergraph is now composed and filtered to only include the public tag. Now, surprisingly, you'll notice that the field's author ID and secret name are still defined, even though they don't have that public tag that we asked to include. And this is because under the hood, Router actually keeps those definitions and filters out by applying @inaccessible directives to the fields that do not have those public tags. And what happens is that Router will use that inaccessible directive to exclude it from being shown to clients. So in this case, clients actually will only see the full name field. They won't actually see secret name or author ID because it has @inaccessible in it. So we might be wondering, why even expose it or keep it there, right? So this is actually by design. This is to help drive resolving other fields using federation directives like @requires. So in this example here, full name, in order to resolve that, we're saying that it requires the author ID field and secret name as well. So this is what Router uses to kind of orchestrate resolving that field, and that's why it's still visible and it still helps drive resolution of the schema. And the takeaway here is that these are all Router planning concerns, right? Clients don't know about these fields. They only care about the full name that they're querying. Now we have our contract variants, and they're generated, right? So this is where Router can actually use those contract variants to expose the API schema to our clients, where any inaccessible fields are hidden from them. So that's pretty much the high level of contracts, and it's what enables us to achieve that one unified graph that we're looking to build. So as you can see from looking at how we're setting up contracts, it's pretty flexible, and there's a lot of ways that you can choose to set up contracts at your organization. When we started doing this about 2 years ago, there was a lot to consider around what rules we wanted to put in place, whether we want to use includes or excludes or both. So let's take a look at that. And to kind of help us get to that decision, there were kind of 3 main factors that we looked at. And it revolved around security, cognitive load, and flexibility. And in our earlier example, as we've talked about, we want to generate a contract that exposes fields that should be public. And we use the includes filter to do that. And with the excludes filter, we can actually achieve that same result by excluding all tags that aren't public, right? So in this case, if I put exclude private, we can achieve that same schema at the end. But there are some implications around how we want to set this up, right? And the first thing we looked at was using excludes only, or what we call a full trust model, right? What this means is that all definitions are visible in the schema unless it's tagged with something to exclude it, right? And this can sometimes be good because there's less tag directives applied everywhere, right? Another upside of this full trust model is that when we create new contract schemas, all existing fields that aren't tagged will appear in the new contract by default. And what we found is that this can sometimes be good, right? So that leads us to the major drawbacks of using the excludes only. Security-wise, it's really unintentional, right? And it's really leaky, because every time you make a new contract, everything just appears. Like imagine if your employee data just got exposed to a public contract, right? So we have to be real careful about exposing sensitive fields to the wrong contracts. So the other major drawback is that when we make new contracts as well, we have to modify the existing filtering rules. So you're basically touching things that you're not supposed to when adding new contracts, so that can lead to a lot of churn and potentially just breaking your schema at the end, right? And for those reasons alone, that's why we've decided to take a different approach. And that's why we went with the includes only approach, because of how secure and deliberate it is. And the include only model is essentially what we call a zero trust model. And this approach means that every field must be explicitly tagged for it to appear in any contracts. Subgraph tagging in this scenario is more intentional, right? Because everything has to be tagged. So that kind of leaves less room for unintentionally leaking those sensitive data to the contracts that you don't want them to be in. And in terms of flexibility, adding a new contract means that we don't have to modify those existing contracts that we already have. We don't have to change the rules, and which also minimizes room for mistakes there as well compared to the excludes only approach. This zero trust model that we went with isn't perfect either, right? So in terms of cognitive load, it's going to be high for our developers and teams because now every single field has to be tagged for them to show up, right? And this can lead to more tagging errors, right? How many of us have been in a situation where you're like, maybe I'm applying way too many directives? And that's exactly what we've kind of dealt with, right? Like getting a bit too directive crazy. Another downside of this pattern is that when adding a new contract, all fields are needed to explicitly be tagged with that new schema contract tag that we're looking to launch. But after some time, what we learned was that this is good. It forced teams to have a conversation. It's not leaky. That employee type we didn't want to leak, if I want that in my new contract, I need to go to that team, have that conversation around whether or not I should be exposing it. So despite some of the drawbacks of this includes-only approach, we were OK with working with that. We wanted to move forward with it. So as mentioned, in regards to being a bit directive crazy, there's a high cognitive load when you apply so many tag directives, right? In this example, there's only 2, but imagine 3 and then 4. You've got to apply it everywhere. And with schemas with 50, 60, 70 types, you run into a lot of composition errors because you're not sure if this type is dependent on the parent type A that needs it or type B, right? So it gets really hard working with a ton of tag directives there. And what I want to highlight is that the default behavior in contracts is that when applying tag directives at the object level, it actually merges those tag directives with the child field levels. So that doesn't really align with our desire for a more secure and deliberate tagging approach, right? So in this example here, the author type, which is in the subgraph schema, we're tagging the public, we're tagging the author type with the public and private tag directives. And then the author ID, we have just the tag private. And what we found and then what happens under the hood is that it actually merges the directives together, right? In this case now, we're unintentionally tagging author ID with the public tag. So unless you tag everything explicitly, you end up with a ton of directives that you apply to your subgraph schema. So to address this undesirable behavior with tagging, we actually implemented custom tagging solutions at Wayfair using our internal schema publishing platform. So it's helpful to know that at Wayfair, every subgraph schema that needs to publish to GraphOS actually is published through our internal schema publishing service. And this service is essentially the hub for all things federated GraphQL at Wayfair, which is what allows us to apply additional linting rules that aren't part of composition, and also apply transformation logic to the schema before publishing it to GraphOS. To get around the tagging complexities, we implemented a custom schema transformation rules for contract tagging. And what that rule does is that it propagates, when tags are applied to an object, it propagates to everything except for things that are already tagged. So same example here on the left, author type has a tag directive with public and private, and author ID has just private. And what our schema transformation logic does is that it will it will propagate those two tags down to fields that don't have anything. And if it does have something like author ID, it doesn't do anything. So in this case, it kind of removes that complexity around having too many tagging directives, right? Which is pretty cool. And we've actually taken this further up to chain, right, and extended it to the schema element. So same idea. Now we've got that hierarchy of parent, children, grandchildren, right? So it goes from schema to objects to field level definitions. So again, every object will inherit the same tag directives from the schema, and then the same propagation occurs again back to the child fields. So this pattern is actually really helpful for us to reduce cognitive load when working with contracts. So we saw this really helpful because subgraph A said, hey, I mostly just contribute 90% of my types to the public contract, and only 5 fields that I have has private. So by default, their schema effectively defaults to just public, right, or private in that matter. So that's a glimpse into how we're using contracts at Wayfair today. It's flexible, and there's a lot of ways to set it up. So at this point, some of us may be wondering or considering contracts, or even federation for that matter, or like or questioning at what point can we adopt federation? Is it too late? And we'll help answer that through how we've done it at Wayfair. So it's important to call out again that when we first ventured out into federation, we didn't have contracts. We started with 3 different graphs, right? And what's important to also note is that when we did adopt contracts, our subgraphs were not rebuilt to support contracts, right? They stayed pretty much the same. And on the client side, that's the beauty of GraphQL. Your schema stays the same, so no breaking changes there either. So adopting contracts to our existing federated ecosystem was actually pretty straightforward. What was nice was that each of our subgraphs application boundaries were already defined, right? The customer subgraphs were already contributing to that one graph, and the employee subgraphs were only contributing to that one graph, and so forth. So we already knew the boundaries. And migrating to contracts was as easy as tagging every subgraph with their corresponding tag and publishing to that new source variant that we talked about. And through schema evolution, each subgraph was able to incrementally apply their appropriate tags. So adopting contracts for us was completely backwards compatible. You don't have to start out federation with contracts. And as I mentioned, because we already knew what subgraphs were contributing to the existing supergraph, we actually expedited that migration process by automatically applying the tag directives at the platform layer for each of those subgraphs. And after that, all we did was double publish to the old graph and the new graph behind the scenes. So, and migrating routers was actually really straightforward. It's really just confirming that our schema stayed the same from when it was in our old graph and in our new contract graph, right? and that was just easy, just verifying that they're semantically the same, and then switching the variants in router, and that was it. So that's how easy it was for us to adopt contracts, right? No matter what stage of GraphQL or federation you're in, it's not too late. So it's been about 2 years since we've adopted contracts at Wayfair, and our teams have been hard at work building world-class experiences with contracts, and it helped us build the contracts at scale. Now we have more cohesion, transparency, and the consistency that we wanted. So before I close this out, I'll show you some of the really cool things that our teams have been building. Some of them are here. So for example, circling back to what we talked about earlier into how important it is for core data like product to be consistent, regardless of the experience it's building. So what you're looking at is our customer service tools that our customer service agent on the phone or on the chat are using to help our customers make kind of additional changes to their orders and things like that. What's nice about this is that our agents are able to see the same exact customer order data that our customer sees on their My Orders page, right? So it's powered by the same types, same resolvers, same services. And this is extremely helpful in these scenarios because we can overlay additional employee admin tooling on top of that shared customer order details in our employee app. So that's what our agency, it's the same exact data powered by the same schema for customer order details. Another example is our physical retail experience that our in-store employees use to browse products with our customers. And that physical retail application provides the same product browsing experiences as our e-commerce site, right? It's crucial that there's great parity here. We want to see the same exact data, and we're getting just that with contracts and by driving the same schema. So yeah, shout out to contracts for that one as well. Finally, this is one of my favorite use cases for contracts. At Wayfair, Block Builder is our internal CMS platform that helps us deliver server-driven UI experiences to our customer-facing applications. So Block Builder allows us to dynamically update the content of our customer-facing components through an internal WYSIWYG tool without deploying code to our customer-facing app. And this is actually where contract shines in building the tooling to support this. And under the hood of both the customer and internal admin view here, they're both powered by the same what we call blocks or GraphQL types shared using contracts. So in this example, it's really important to have that great parity so that when we're kind of editing the components in our internal tool, it's important that we're going to see the same exact results back on our front-end customer-facing applications. So that's GraphOS contracts and a glimpse into what our teams have been building at Wayfair. There's so many ways to use it. And with the rise of AI and examples from today's keynote, you can even consider picking out AI-safe schemas using contracts, right? So many ways to use it, really powerful stuff. And yeah, that's all I'm going to leave you with. That's all I have. And looking forward to connecting with you all at this summit. Thank you.